Let's look deeper at the metric system. All right, so again, we have all sorts of different units of measure that we look at. And so in science, we use the metric system. And hopefully, once you've worked with the metric system for a while, you will start to understand why the metric system is a really good system to use for measurement. It's interesting, when I was growing up, we kept talking about how the US was going to switch to the metric system, and the signs around town that said how far your distance was from one place to the next as you're driving were all in miles, but they had an extra piece tacked onto them that was in kilometers to get everybody ready for this switch over to the metric system. And those extra tack-ons aren't there anymore. We never actually made the switch to the metric system. So we have two systems we have to take into consideration. Okay, so we have our metric prefixes. There's a whole bunch of them, but there's some that you will see more than others. So we have our base unit, the meter, liter, gram. So we talk about kilograms. So kilo means that we have 1,000 grams for every kilogram. So kilogram is really large. It takes a lot of grams to make up a kilogram. And then we have our smaller units, deci, centi, milli, micro, nano. So centimeters we use a bunch. So meters are base unit. It takes 100 centimeters to make up 1 meter. Liter, we use milliliters in the lab. Liters, the base unit, it's 1,000 milliliters to make up a liter. So we can look at these in different, contexts when we think about takes up a whole lot of the little units to make up the big unit. Okay. Now, one thing that we have to do quite a bit is convert. So I mentioned that when we go from even just the base metric system to the international system, sometimes we have to convert. So like I might record something in the lab in centimeters, but when I go look up a table of known data, the known data might be done in meters instead of centimeters. And so if I want to compare numbers to see how accurate my number is to the recorded number, I might either have to convert my number to meters or convert the known number to centimeters so I can have the same basis of comparison. Okay, and then obviously there's a lot of English metric that has to be converted, and that's a really important one. In fact, when conversions haven't been done correctly, we've done things like crashed really expensive landers into other planets because we descended them too fast, because firm A that built part of it and firm B that built the other part of it, one worked on the English system, one worked on the metric system. Somebody didn't convert something, and boom, crash, explode, lots of money, lots of time, went up in smoke. So conversion factors, they allow us to go from one unit to another. So anytime we have an equality, we can turn it into a conversion factor. And so what we'll do is we will set it up such that the units we want to get rid of cancel out, and the units we want to convert to end up getting moved into that. Okay, so we can look here. All right, so we have 24.0 centimeters. So I have the calculation written here, but we're going to go over this. So 24.0 centimeters. I want inches. So I'm going to go from centimeters to inches. Okay. Now we have a conversion factor that lets us go between centimeters and inches, and that is 1 inch is equal to 2.54 centimeters. Okay, so I start off with my 24.0 centimeters. Okay, and now I need to convert that to inches. So I need to cancel out centimeters. Okay, so I can think of my 24.0 as being 24.0 over a unit plus 1 if it helps, right? Or we can just have our 24.0. Okay, so I want centimeters to cancel out. So if I have centimeters on the top, then I need it to cancel out on the bottom. So my 2.54 centimeters will go here on the bottom, and my 1 inch will go on the top. Okay, so centimeters and centimeters cancel, and I'm left with inches. So then I get a calculator, I do the math, and I end up with this 9.45 inches. We're reporting the answer to 3 significant figures because here I have 3 significant figures. Now, sometimes conversion factors will also affect your significant figures. Usually metric US, that does affect your significant figures, but here's the thing. We actually have defined 1 inch is exactly 2.54 centimeters. I can put another line here to show that it's actually an equality. So that one's not going to affect your significant figures because we have defined 1 inch as 2.54 centimeters because we have to have a reference point with which we do our conversions. Okay? All right, now we're going to be doing a lot of different converting throughout our study of chemistry. So let's try a few more. All right, so we want to do 4.6 centimeters to nanometers. Okay, so what we're trying to do is go from centimeters to nanometers. Now this is metric, so it's all just powers of 10. So we don't have to use our conversion factors for our significant figures. Our significant figures will be done by our base measurement. Now there's 2 ways that we can do this. We can go directly from centimeters to nanometers, or we can actually go from centimeters to our base unit of meters and then back down to nanometers, which I found for a lot of students is very helpful than trying to figure out how to adjust all the exponents between centimeters and nanometers. So I can go centimeters to meters, and then meters back down to nanometers. Okay? All right, so I have 100 centimeters equals 1 meter, and then I have 10 to the 9th nanometers equals 1 meter. Takes a lot of nanometers to make a meter. Okay, so nanometers is a teeny tiny unit. I need a ton of the teeny tiny unit to make the base unit. Okay, so to do this, we're going to do our 4.6 centimeters. Okay, we need centimeters on the bottom, so I'm going to do 100 centimeters on the bottom and 1 meter on the top. And then here I want nanometers on the top and meters on the bottom. So I'm going to do 10 to the 9th nanometers in 1 meter. Okay, so centimeters and centimeters cancel, meters and meters cancel. And I end up with 4.6 times 10 to the 7th nanometers. Okay. All right, so there's our first example. Okay, next we're going to try milliliters to liters. Okay. All right, we have 1,000 milliliters is equal to 1 liter. Okay, so 750 milliliters times 1 liter on top, 1,000 milliliters on bottom. We're going to get 0.750 milliliters. Now, whoever took this measurement didn't do a very good job because there's no decimal point in that 750, which means this number has only 2 significant figures. So when I do my conversion, I can only report it to 0.75 milliliters. I mean, 0.75 liters. Ack! We're going from milliliters to liters. Okay, so we get 0.75 liters. All right. Now we're going to do deciliters to milliliters. Okay. Again, we can go through our base unit. So I'm going to do deciliters to liters to milliliters. So I have 10 deciliters equals 1 liter, and I have 1,000 milliliters equals 1 liter. So we have 0.85 deciliters times 1 liter for every 10 deciliters times 1,000 milliliters for every 1 liter. Okay, so deciliters cancel, liters cancel, and I'm left with milliliters. And we're going to get 80. But there we go, 85 milliliters. Okay. All right, so now for these next few, I'm actually not going to write out the whole answer. The whole solution. I'm only going to give you the final answer because I want you to try these. So we have a recommended daily allowance of phosphorus for an adult male is 800 milligrams. So how many grams of phosphorus are recommended? So you're going to go from milligrams to grams, okay? And the answer is going to be 0.8. Okay. All right, next is centimeters to meters. So 175 centimeters, how tall is that in meters? So you're going to go centimeters to meters, and you're going to get 1.75 meters. Okay. And then our last one, we have kilograms to grams, and that should be 5.5 grams. So try these 3. See if you can replicate the answer that I got. If not, look back through the videos, look at the conversion factors, try to set it up again, and if you still can't get it, that's a really good time to pop into office hour and have me go over it with you in real time, one-on-one. Okay. So there's a whole bunch of conversion factors to think about. We've got all of these US to US conversions, there's all the metric conversions, and then there's the metric US conversions. So these can be really practical too. I've used these in like a normal setting. So let's see here. My daughter, when she was born, they weighed her in kilograms, and my husband does not speak metric. He has a degree in English, so he doesn't speak metric. So he asked the nurses what she weighed in pounds and ounces, and the nurses just kind of went, and they totally forgot how to do the conversion. So I had just given birth, and I had to sit there and do math and convert kilograms to pounds for my husband. When we have a camping trailer, and so when we bought our camping trailer, my car only has a 3,500 pound tow capacity. So we had to be really careful about all the weights. And so the dry weight of the trailer was around 2,500 pounds. And we did not want to max the tow capacity on the car. I drive an Escape. And so what I did sitting in the sales office at the place where we bought the trailer was I took the water tank, the number of gallons of water it held, and I converted using the density of water from gallons over to pounds to figure out, all right, like can we only camp where there's hookups with water, or can we dry camp? Can we fill the water tanks and then tow the trailer successfully and camp somewhere where there aren't hookups? Like, how much weight is that going to add to the trailer? So, because that was something I wanted to make sure before we actually bought it. And when I asked the salesperson, okay, well, how much weight does the water add? The salesperson was like, well, it's X number of gallons. I'm like, all right, I'll do the conversion myself. So very practical use for conversions. Okay, so these, you'll